The cosmos is full of surprises, but sometimes the stars whisper things we were never meant to hear. Just days ago, the James Webb Space Telescope caught something so strange, so out of place, it forced scientists to stop in their tracks. And the truth, hidden in the data, is both fascinating and terrifying. Subscribe now, because what you're about to hear may change the way you look at the night sky forever. Now let's set the stage. Imagine the cold, dark expanse beyond Mars, a place where sunlight is little more than a memory, where shadows stretch endlessly. It was here, in this forgotten region of space, that Webb's golden mirrors turned toward a target catalogued simply as an interstellar visitor, 3I Atlas. At first, nothing seemed unusual. Another comet, another piece of ice and rock wandering through our solar system. But then, Webb's sensors began to record something no one expected. Light. Not reflected sunlight, not scattered starlight, artificial light. A glow that pulsed with rhythm, as though it had a heartbeat. Scientists leaned in closer. Instruments recalibrated. Data streamed. And what they found shook even the most skeptical minds. The chemical signature of the Atlas wasn't natural. Ratios of elements were out of place, heavy metals arranged in ways comets simply don't form. Its tail behaved like no comet tail ever observed. Instead of flowing chaotically, it flickered like a controlled engine burst. And then came the glow, not diffuse, not scattered, but directed. A pinpoint of illumination, like a lantern burning in the void. Webb's team couldn't look away, because this wasn't just a comet anymore. This was something else, something that refused to follow the rules, something that, for the first time in decades, reignited a terrifying question. What if we aren't alone? Scientists have always treated light as one of the universe's simplest truths. Stars shine, planets reflect, comets scatter sunlight through dust and ice. But what Webb captured from 3I Atlas was none of these. Instead, the light came in pulses, sharp, precise, almost deliberate, like the ticking of a metronome in the dark. Each burst carried a pattern, a rhythm, too regular to be random. At first, the team wondered if it was just interference. Maybe Webb was picking up echoes from a satellite or some quirk of its own sensors. But cross-checks from Hubble and the European Space Agency's deep space arrays showed the same thing. The glow was real, and it was coming from the object itself. Imagine sitting in a silent room and suddenly hearing a faint tapping. Not thunder, not the wind outside, but a rhythm. That's what astronomers were experiencing. Space had always been noisy in its own way, filled with radiation, solar flares, and the background hum of the cosmos. But this felt different. Almost like a knock at the door. The light wasn't the only anomaly. As Webb's spectrographs broke it apart, the colors revealed chemical fingerprints no natural comet should possess. Instead of simple ices and dust, the readings showed an excess of metals, titanium, vanadium, and traces of alloys more common in engineered objects than wandering space rocks. To many in the control room, it looked less like nature's handiwork and more like machinery. The question no one wanted to say out loud began to echo quietly. What if this wasn't a comet at all? What if we were staring at something built? Of course, in science, words like alien or artificial are rarely spoken lightly. They invite ridicule, career-ending headlines, or worse. And yet, the data refused to behave. No natural explanation fit neatly. It was as if the universe had left a riddle in plain sight, daring humanity to solve it. The glow shifted again, this time aligning with the comet's rotation. Like a lighthouse beam sweeping the cosmos, it flashed across empty space, steady, unwavering. To the untrained eye, it might have been just another anomaly, but to those watching closely, it felt like a signal. A message carried not in words, but in rhythm and light. And here's where the story begins to deepen. Because 3I Atlas wasn't just drifting, its course had changed subtly, but unmistakably. As if nudged, as if guided, as if it wasn't wandering freely through the void, but being steered. When scientists first noticed the shift in the path of 3I Atlas, they thought it might be an error, a miscalculation, perhaps even noise in the instruments. After all, interstellar objects are tricky to track, tiny, fast, and unpredictable. But the math didn't lie. The object wasn't following the clean arc expected of a comet. Instead, it made a subtle adjustment, almost like a pilot correcting course. This wasn't the first time humanity had seen a visitor from the stars. In 2017, the world was captivated by the discovery of Oumuamua, the first interstellar object ever detected passing through our solar system. At first, astronomers thought it was a comet or asteroid, but its shape, its speed, and its acceleration defied expectations. It didn't behave like a rock or a ball of ice, it behaved like something else. Harvard astrophysicist Avi Loeb even suggested that Oumuamua might have been a probe or at least debris from an advanced civilization. Years later, another interstellar traveler arrived Borisov. Unlike Oumuamua, Borisov looked more like a traditional comet, shedding dust and gas as it flew by. It reassured scientists, in a way, that maybe Oumuamua had been an odd outlier, a cosmic fluke. But now, 3I Atlas was rewriting the story again. Because unlike Oumuamua, this one didn't just drift through space. It lingered. It slowed. And most disturbingly, it seemed to split. The detection of a second body, trailing close behind, raised questions that no one wanted to answer. Was this fragmentation, the way comets sometimes break apart under pressure? Or was it something more controlled, like two pieces of a craft working in tandem? What unsettled scientists most wasn't just the split, but the timing. The secondary object appeared right as the light pulses intensified, as if one phenomenon triggered the other. And the two objects didn't simply scatter, they moved together, maintaining formation, like dancers in an endless cosmic waltz. NASA's Jet Propulsion Laboratory ran simulations. If these were just broken pieces of the same comet, their orbits should have diverged. Instead, they stayed locked, side by side, as though tied by invisible strings. Nothing in physics prevented such behavior, but nothing natural explained it either. This wasn't just movement, it was coordination. And coordination suggested intent. The deeper the team dug, the more uneasy they became. This wasn't just another cosmic traveler. It wasn't Oumuamua. It wasn't Borisov. It was something else entirely. And whatever it was getting closer, not just to Mars, but to us. As news trickled out of NASA, unease spread beyond the walls of mission control. Officially, nothing had been confirmed, just whispers about anomalous readings and cometary behavior under review. But behind closed doors, the tone was far less cautious. Engineers reviewing the raw telemetry noticed something chilling. The pulses from 3I Atlas were not random. They weren't the messy outbursts of a comet throwing off gas. They carried rhythm, structure, a repeating signature that defied coincidence. Every 17 minutes, like clockwork, the instruments picked up the same burst of light, the same shift in energy. At first, it looked like a simple spike, but once the data was cleaned and amplified, something else emerged. Patterns. Patterns so precise that one scientist compared them to binary code, ones and zeros, hidden in the flashes of light, as if someone or something was transmitting. The idea was almost too dangerous to say aloud. If this was true, then 3I Atlas wasn't just splitting apart. It wasn't just glowing. It was talking. Or at the very least, signaling. To keep the story quiet, NASA restricted access to the deeper logs, pushing only partial data to the public servers. But even then, amateur astronomers caught on. Telescopes across Europe and Asia confirmed unusual brightness variations. Online forums buzzed with speculation. Some thought it was just equipment glitching. Others believed it was the first real attempt at interstellar communication. Inside the European Space Agency, one researcher described the pulses as nested harmonics, tones within tones, like a choir layered in space. Another suggested the light wasn't reflecting, but projecting, as though the object itself was engineered to broadcast across the void. And here's where the real fear began to build. The second object, the fragment traveling beside it, was responding, not with light, but with faint magnetic shifts detected by Earth's most sensitive instruments. One body sent light, the other sent magnetism. Together, they formed a pair, a system. Suddenly, the question wasn't whether 3I Atlas was natural or artificial. The question was, if this was communication, who was it meant for? Was Earth the intended audience? Or was this exchange between two interstellar objects, speaking across the void, while humanity simply overheard? What unsettled the scientists most was not the discovery itself, but the silence of those in charge. NASA, ESA, and JPL avoided public comment, giving the impression of calm. But the data told a different story. Teams working day and night, simulations running endlessly, private calls with military and intelligence officials. The public saw a comet. The scientists saw a message. And those with the highest clearance knew it was something else entirely. Scientists working on the ground weren't just puzzled, they were conflicted. Some believed the data pointed to a natural explanation, a fragmenting comet under tidal stress, venting material in unusual ways. Others argued that the signals were far too consistent, far too clean. One astrophysicist quietly admitted to a colleague, if this is a comet, it's the most disciplined comet I've ever seen. In hushed tones, the phrase began to circulate through the research community. Artificial object. Of course, nobody dared put it in writing, at least not in an official report. But leaked snippets began to appear in obscure forums, written under pseudonyms, describing what was happening behind the closed doors of NASA and ESA. What made the situation worse was the second body. The fragment, as it was initially called, did not behave like a simple chunk of ice and rock torn from a comet. Its motion wasn't random. In fact, its trajectory seemed deliberately synchronized with the primary object, as though the two were locked in a dance. When the main body pulsed with light, the fragment shifted position as if adjusting its stance in reply. At the Pentagon, this was no longer treated as just a scientific anomaly. Military advisors started asking uncomfortable questions. If this was artificial, could it pose a threat? Could the object maneuver closer? Alter its path toward Mars, or worse, Earth? Satellites were tasked with constant monitoring. Secure communications bounced between Washington, Brussels, and Houston. And yet, the public was told almost nothing. NASA continued to present the discovery as a rare opportunity to study interstellar dynamics. But deep down, every scientist in the know was feeling the same cold weight in their chest. This wasn't dynamics. This was control. Then came the comparison no one wanted to make, but everyone eventually did. Oumuamua, the first interstellar object ever observed in our solar system back in 2017. Its strange elongated shape, its bizarre acceleration without explanation, and the theories, yes, even from Harvard's Avi Loeb, that it could have been artificial. Back then, the scientific community had scoffed, brushing aside such bold claims. But now, years later, staring at 3I Atlas and its companion, the parallels were undeniable. And still, the signals came, 17 minutes apart, each one as precise as the last. Data analysts began mapping them across time, creating visual graphs of light patterns. When the graphs were printed out and laid side by side, the shapes they formed weren't random. They resembled sequences, instructions, perhaps even a message. One young researcher, overwhelmed by the implications, reportedly said, "We're not just looking at a comet, we're looking at a system built to be seen." And if that was true, then the world had just been noticed. Behind the scenes, the meetings grew longer and the silences heavier. NASA's Jet Propulsion Laboratory submitted technical logs that seemed routine on the surface: spectral lines, trajectory projections, fragment data. But hidden in the attachments were flagged anomalies. Analysts noticed that when the larger body emitted its pulse, the smaller fragment didn't just shifted aligned, like two hands moving in rhythm. It was too clean to ignore. At the Pentagon, the classified briefings turned almost philosophical. Was this a weapon, a probe, or something humanity simply lacked the vocabulary to describe? The Department of Defense, not usually quick to entertain the extraordinary, began pressing NASA for scenarios. What if this object adjusted its orbit toward Earth instead of Mars? What if the second body wasn't a fragment, but a module, an extension? But inside the scientific circles, the debate became even sharper. Some argued for transparency. Release the raw data. Let the public see the light curves, the repeating intervals, the eerie synchronization. Others insisted on silence. Do you want panic? One European Space Agency official reportedly said during a late-night call. Because if this gets out without context, that's exactly what you'll get. Yet, despite all the precautions, whispers found their way online. Amateur astronomers, with telescopes far less powerful than Webb, began reporting strange irregularities in the comet's light. Threads appeared in forums. Posts were taken down, accounts suspended, but as often happens in the digital age, the act of censorship only made the story spread faster. And through it all, the pulses continued 17 minutes apart, like a ticking clock. 17 minutes, then another. 17 minutes, then another. A rhythm so steady that one scientist privately described it as a countdown. If that was true, the question no one dared to ask was, counting down to what? It was around this time that the first leaks began to slip into the public sphere. Not from NASA press releases, not from polished reports, but from whispers and anonymous uploads. A blurry screenshot from a monitoring station in Hawaii appeared on a private astronomy forum. It showed two distinct signatures in the same orbital path, the larger object and something smaller, trailing like a shadow. Within hours, the post vanished, but not before dozens of amateur skywatchers saved it, copied it, and passed it along like a secret too heavy to keep. Then came the audio. A strange low-frequency hum recorded by a hobbyist with a magnetometer rigged in his backyard. At first, people dismissed it as interference. But when analysts compared the timing of the hum to NASA's own logs, the match was eerie. Every 17 minutes, the same rhythm, the same pulse. Conspiracy channels lit up. Some swore the fragment was a probe. Others argued it was nothing but cosmic debris. But buried beneath the noise, a few careful voices raised a chilling possibility. The pulses weren't random. They carried a structure, a repeating order, almost like data packets being transmitted. Inside NASA, this suggestion was treated like dynamite. Engineers quietly ran Fourier transforms on the signals. They filtered the noise, compared the intervals, stretched the waveforms. And when they did, something emerged, tiny spikes, positioned like markers in a code. Not enough to decipher, not enough to prove intent, but just enough to raise the question that none of them could answer. Was this comet fragment transmitting? The world outside, of course, knew nothing of this. To the public, 3I Atlas was still just a strange, broken comet near Mars. But behind closed doors, some scientists were starting to whisper words no one expected to hear in a research briefing. Communication, synchronization, intent. And as the 17th minute pulses kept ticking, like a metronome from the stars, one phrase began spreading quietly among the analysts who studied it. Not a conclusion, not even a theory. Just a question that wouldn't go away. If this is a message, who is it for? While signals and pulses kept scientists awake at night, telescopes turned their gaze to Mars, where the split object, if that's truly what it was, had drifted dangerously close. Mars, the planet that has long been a symbol of exploration, now found itself sharing its orbit with a visitor unlike any we've seen before. At first, NASA and ESA engineers thought it was nothing more than a typical fragmentation event, the kind we've seen with comets breaking apart under heat or gravitational stress. But as the days passed, the smaller body refused to behave like a passive piece of debris. Instead of spinning wildly and scattering dust, it held formation. It almost followed. For those working with the Mars Reconnaissance Orbiter and the European Trace Gas Orbiter, this was no small concern. Even a fragment only 100 meters wide could endanger billion-dollar spacecraft. And if its trajectory shifted closer, Mars's fleet of orbiters could be at risk of collision. Quietly, flight teams began running emergency calculations, exploring contingency maneuvers that would normally only be used in extreme cases. But then came something even stranger. From the surface of Mars, rovers like Curiosity and Perseverance are constantly recording environmental data. One of those readings, barometric pressure, of all things spiked in an unusual rhythm. When the data was matched against orbital tracking of the fragment, the spikes aligned almost perfectly with its overhead passes. The timing was uncanny. It suggested that whatever this object was, it was influencing the thin Martian atmosphere in ways no ordinary cometary fragment should. Was it venting? Was it emitting some kind of energy? Or was Mars itself reacting to the presence of an interstellar visitor? Meanwhile, in quiet corners of government offices, another question arose. If this fragment could influence Mars, could the same debris someday find its way to Earth? After all, fragments don't always stay where they begin. They wander, they drift, and sometimes they fall. For now, the official line remained cautious. A comet split, an unusual one, yes, but still natural. Behind the curtain, though, there was urgency. Models showed that even the smallest miscalculation in its orbital path could send the fragment brushing Mars's atmosphere. And if it did, the event would be visible from Earth. A flare, a burn, a scar carved into the red planet's thin skies, telling the universe that 3I Atlas, or whatever it truly was, had made its mark. And the strangest part of all? Every 17 minutes, the pulses kept coming, as if marking time, as if counting down. As scientists kept a careful watch on the twin bodies of what was once called Atlas, the pulses it emitted became the centerpiece of a global debate. Every 17 minutes, the same flicker. Not a flare, not random venting, but a precise, consistent pattern. In nature, precision at that level is rare. In technology, it is everything. Data analysts across NASA, ESA, and even independent observatories began to stack the recordings against one another, building charts and waveforms that looked less like noise and more like music. Some saw rhythms, like the beats of a drum. Others claimed to see binary patterns, ones and zeros, hidden within the faint whispers of light. The question was simple, but terrifying. Was this object trying to communicate? Of course, Skeptics rushed to the front. They argued that comets are strange beasts full of hidden chambers, rotating irregularly, venting gas in ways that can mimic order even where there is none. But the longer the pattern persisted, the harder it became to dismiss. After all, comets fall apart. They shed tails. They fade. They do not tick like clocks. To stretch the mystery further, an unusual coincidence began to emerge. When plotted on a planetary calendar, the pulses lined up eerily close to Mars's orbital resonances. As if the timing was not just arbitrary but chosen. As if the fragment was syncing itself with the very heartbeat of the red planet. And then came the silence. For exactly 24 hours, no pulse was recorded. Telescopes strained, antennas searched, data centers combed the heavens for a missing signal that had, until then, been as faithful as sunrise. The world held its breath, and then, suddenly, at the 25th hour, the pulses returned. But they were different. This time, the signal doubled. Not one flicker, but two. A twin pattern, echoing the split of the object itself. The fragment had found its voice, too. For the scientists who believed in coincidence, this was the breaking point. For the rest of us, it was the moment the story changed forever. Because now, it wasn't just a question of what Atlas was. It was a question of who or what was controlling it. As the world reeled from the double signal, a more practical question emerged. What if this was no longer a mystery to simply observe, but a threat to prepare for? The reality of Atlas, this interstellar wanderer turned anomaly, was that it was no longer behaving like a simple fragment of rock and ice. It was coordinated, timed, predictable in ways that comets rarely are. And with Mars directly in its path, the stakes could not be higher. Imagine, for a moment, what impact means on a planetary scale. If Atlas or either of its fragments struck Mars, the crater could span tens of miles, and the shock waves would not end there. Mars is not an empty wasteland. It is filled with orbiters, landers, and dreams. The Perseverance rover, the Ingenuity helicopter, ESA's Trace Gas Orbiter, NASA's Odyssey, still working after 2 decades. Entire constellations of satellites hang above the red planet, watching and listening. All of them would be at risk of destruction. But worse than the immediate loss of machines was the unknown chain reaction. Dust clouds from a Martian impact could scatter across the solar system. And in the silent halls of astrophysics, whispers grew of a darker possibility. Could fragments hurled loose from Mars be nudged Earth's way? NASA and ESA began running scenarios. Some whispered of kinetic interceptors missiles launched not to explode, but to nudge Atlas off course by mere fractions of a degree. Others imagined nuclear devices detonated nearby to vaporize surface ice and create thrust. Yet all of these options shared one cruel problem: time. A few months was not enough to build, test, and launch planetary-scale defenses. And so humanity faced the oldest cosmic truth of all. Sometimes the universe gives no warning. Sometimes it simply delivers. Yet, even in the face of that grim reality, one detail kept scientists awake at night: the pulses had changed again. Not in timing, not in rhythm, but in direction. They were no longer broadcasting aimlessly into the void. They were aligned, pointed, and the vector, when charted across the solar system, led unmistakably toward Earth. At first, the change seemed subtle, a small tilt in the vector of pulses, nothing more than a few degrees. But in astronomy, degrees matter. A single degree can mean the difference between harmless passage and catastrophic encounter. And as teams in NASA, ESA, and even Japan's space agency checked their numbers, the realization sank in the pulses were being aimed toward Earth. For days, the world outside never knew. News headlines remained locked on politics, markets, and the slow churn of daily life. But behind sealed doors, in conference rooms where cell phones were banned and laptops carried warning labels, the conversations grew darker. Was this a message? A test? Or the first act in something far larger than anyone could imagine? The signals were not static noise. They were layered, structured, and repeating in cycles of 17 minutes. Imagine a heartbeat steady, unbroken, unrelenting. Scientists fed the data into translation models, into AI systems trained on every known human language and countless mathematical codes. No answers came. But there was one undeniable truth. This was not random. Some researchers argued for caution. Perhaps the pulses were navigation beacons guiding Atlas and its twin fragment through space. Others insisted the signals were meant to be heard by us. And one chilling possibility loomed above all. What if the pulses were not just being broadcast outward, but were scanning, searching, probing Earth's magnetic field, atmosphere, or even the networks of satellites that circle above us? It was during one of these tense meetings that an engineer from ESA made a quiet but unforgettable remark. She pointed to the synchronized data and said softly, "It's like it's knocking, just waiting for us to answer." Knocking, waiting, a thought that echoed long after the meeting ended. And so humanity stood on the edge of a choice: to remain silent, observers in our own solar system, or to risk replying, knowing that once we spoke back, we could never again claim to be alone. The argument began quietly, almost academically. At first, it was framed as a scientific question. Should humanity attempt to reply to the pulses? After all, we've sent signals before. From the Arecibo message in 1974 to the Voyager Golden Records launched into interstellar space in 1977. But those were gestures of curiosity, hopeful whispers cast into a silent void. This was different. Atlas, or what was left of it, was not silent. It was already speaking. And the rhythm of its signals suggested intelligence, or at the very least, intention. Some said it was reckless to reply. Others argued it was reckless not to. In Houston, engineers brought up practical risks. Satellites orbiting Earth were already feeling subtle disturbances in communication bands during the pulse windows. A reply might amplify the interference. And if Atlas was scanning us, responding could mean revealing more than we intended. Our frequencies, our technology, even the vulnerabilities in our orbital grid. Across the Atlantic, European scientists took a more philosophical angle. If this was intelligence reaching out, perhaps it was a chance to prove humanity's readiness not for war, but for conversation. One astrophysicist asked, "If we stay silent, what message does that send? That Earth is afraid, that Earth is not worth contacting." But the military voices in the room saw it differently. To them, silence was survival. Once you reveal yourself in a game of strategy, you give away position and intent. And perhaps, they warned, Atlas's pulses were not communication at all, but bait and net, cast across space to see which civilizations would bite. Imagine the weight of that choice. Billions of lives, entire futures, balanced on the decision to send or not send a reply. And then, a quiet discovery made the debate even harder. Buried within the layers of 17-minute cycles, a pattern emerged. Not just a rhythm, but a sequence of primes. Prime numbers, universal, unmistakable, a language of mathematics shared across any intelligence capable of counting. It was as if Atlas wasn't just knocking, it was introducing itself. The silence in the conference halls that followed was suffocating. Because now, silence wasn't just an option, it was a statement. If humanity refused to reply, the refusal itself would be an answer. And so, under secrecy, work began. Not on whether to reply, but on what to say. The news of Atlas splitting into two was strange enough. But what really began to haunt scientists wasn't just the sight of a second fragment, it was how the two pieces behaved. Normally, when a comet or interstellar object fractures, the pieces drift apart unpredictably. Dust and ice scatter into messy trails. Debris forms glowing tails, and their paths wobble under the pull of gravity. But Atlas did something different. The first fragment held its course steady, as though nothing had changed. The second fragment, instead of drifting away chaotically, seemed to shadow the first with eerie precision, almost as if tethered by an invisible cord. Instruments detected faint pulses between the two, bursts of energy at perfectly timed intervals. To some, it looked less like fragments of a rock and more like synchronized partners, two dancers in the void, moving to a rhythm only they could hear. NASA's Deep Space Network tracked these pulses carefully. They weren't random. The spacing between each signal matched a pattern. 17 minutes apart, exactly the same rhythm seen weeks earlier in Atlas's gas emissions. The odds of two fragments carrying on the exact same heartbeat after a violent split were so small that statisticians at JPL described it as impossible. Some theorists began whispering a darker possibility. What if the split wasn't an accident? What if it was intentional? A kind of division, a replication. At observatories across the world, astronomers worked late into the night, unable to look away. Imagine sitting at a console, watching two objects billions of tons in mass behave with a precision that makes no sense. You want to call it natural, but deep inside, your instincts whisper otherwise. The European Space Agency's team compared Atlas's strange twin to historic cases like Shoemaker-Levy 9, the comet that broke apart before slamming into Jupiter in 1994, but where Shoemaker-Levy scattered into 21 uneven fragments, Atlas produced just one neat, deliberate, symmetrical. And then, something even stranger. Telescopes recorded faint glimmers along the surface of the second fragment, but they weren't reflections of sunlight. They pulsed. Tiny, artificial-looking points of light arranged in straight lines like windows on a dark ship. Astronomers argued fiercely about what they were seeing. Some insisted it was simply outgassing jets of material caught in the right angle of light. Others, however, stared at the images and felt a deep unease, because no natural comet tail or gas jet ever aligned itself in such neat, grid-like fashion. One scientist reportedly muttered, "It's not breaking apart, it's reproducing." By the end of that week, the fragments were no longer drifting as one. The second object had begun to change course slightly, almost imperceptibly, nudging its path not away from Mars, but closer. For mission controllers, the unease grew into alarm, because if the first Atlas fragment represented danger, the second represented something worse, unpredictability. If Atlas was more than just a comet, if it was guided or designed, then a duplication meant strategy, a plan. And for the first time in this unfolding drama, whispers of something unthinkable began to spread in hushed tones across agencies. Maybe we weren't just observing a cosmic accident. Maybe Atlas had just revealed its next move. The world's eyes were fixed on Mars, but behind closed doors, agencies were focusing on the one question that no one wanted to ask out loud. What happens if the second fragment isn't just a rock? NASA's Jet Propulsion Laboratory quietly ran simulations, inputting the data as if the fragments were maneuvering objects rather than drifting debris. The results were unsettling. Both objects displayed corrections far too precise for random gravitational nudges. Tiny changes in trajectory that required bursts of force as though engines were firing. Across the Atlantic, at the European Space Operations Center, analysts noticed something else. The second fragment's path wasn't just shifting toward Mars, it was shifting with purpose. Each micro-adjustment lined up along a calculated arc, not unlike how spacecraft perform orbital insertions. It wasn't just drifting, it was navigating. Scientists scrambled for comparisons. Natural comets don't behave this way. When comets split, one fragment almost always tumbles, shedding dust chaotically until it disintegrates. Shoemaker-Levy 9 had crumbled like glass before colliding with Jupiter. Atlas, however, held together. Its second fragment gleamed faintly, stable, and unnervingly deliberate. Astronomers began checking archives, revisiting every observation of interstellar visitors. Oumuamua, the first interstellar object ever detected in 2017, had shown bizarre acceleration that some dismissed as outgassing. Borisov, in 2019, had behaved more like a traditional comet. But Atlas was rewriting the rulebook entirely. Theories multiplied. Some whispered about self-replicating probes, machines designed to split and multiply like seas drifting across galaxies. Others raised the possibility of an unknown propulsion mechanism buried under layers of ice and dust. And a few though hesitant, dared to ask if we were witnessing the first undeniable sign of engineering beyond Earth. Meanwhile, the data pulses between the two fragments continued. The 70-minute rhythm beat on, steady as a cosmic heartbeat. Engineers monitoring the transmissions began noticing sub-patterns nested inside the pulses, like hidden codes. The resemblance to digital communication was impossible to ignore, and yet no official statement came. Publicly, NASA described Atlas's behavior as interesting but inconclusive. ESA called it a rare but natural cometary event. But those who had seen the raw data knew the truth. The split had changed everything. Because Atlas wasn't just passing through anymore. It was interacting. And whatever game it was playing, Mars was at the center of the board. Mars has always been our testing ground for the future of humanity. It holds our rovers, our orbiters, our fragile foothold in a cold and silent desert. And now, with the arrival of Atlas and its mysterious twin, every machine we've placed there could be standing in the crosshairs of history. Take NASA's Perseverance rover, sitting in Jezero crater, still quietly scanning the rocks for hints of ancient life. Its cameras, never meant to look toward space, may soon catch glimpses of the passing fragments, streaking as ghostly arcs across the thin Martian sky. For the engineers in Pasadena, Perseverance has become more than a machine. It's a symbol of our endurance. To think of it standing helpless beneath two massive interstellar objects was enough to make stomachs knot. High above, orbiters like Mars Reconnaissance and the European Trace gas orbiter were at risk too. If even small debris was shed by Atlas, it could shred through these spacecraft like bullets through paper. Years of exploration, millions of images, thousands of experiments, all could vanish in an instant. And then came the elephant in the room: human missions. Elon Musk's SpaceX Starship prototypes were already being prepared for the first cargo flights to Mars. The dream of settlement, of making life multi-planetary, depended on a fragile dance of windows and trajectories. If Atlas or its twin altered the orbit of Mars by even a fraction, it could throw decades of mission planning into chaos. Behind closed doors, agencies began arguing over contingencies. Do we risk sending more hardware toward Mars, knowing it could all be lost? Do we consider evacuation paths for orbiters? Do we even try to nudge Atlas away, knowing the forces involved are beyond comprehension? Meanwhile, the fragments pulsed on, steady as a clock, their signals washing over the thin Martian atmosphere like a whisper. Some scientists began to notice resonance effects, faint ripples in the magnetic environment of Mars itself, as though the fragments weren't just passing through, but deliberately probing, searching, listening. And then came a chilling thought. If Mars was their focus, if these fragments were steering with purpose, then maybe, just maybe, the planet we thought of as our next home was already occupied. While the fragments moved in silence, Earth was anything but silent. Behind the polished statements given to the public, phrases like routine monitoring and no cause for alarm, the truth was darker. Governments were scrambling. In Washington, Pentagon analysts pored over the Webb telescope data, running it through algorithms originally designed to detect nuclear launches. The result? Patterns. Not just random pulses, but structured intervals, like Morse code without the dots and dashes, something that looked eerily like intent. In Moscow, whispers spread through Roscosmos. Their aging satellites around Mars had gone dark for several hours, only to return with corrupted memory banks. The fragments hadn't just passed, they had reached out, touched, and tampered. The word interference began circulating, though no one dared to speak it aloud. China, meanwhile, accelerated its secretive Tianwen program. Their deep space probes, some believed to be military in disguise, shifted course ever so slightly, aligning toward the projected path of the Atlas fragments. It wasn't cooperation, it was competition. If these objects held secrets, Beijing intended to be first to unlock them. And in Europe, ESA scientists leaked their own internal memos. One message, later scrubbed from the internet, claimed that the secondary object wasn't trailing Atlas by accident. It was maneuvering, adjusting its orbit in ways that no natural body could, like a shepherd guiding a flock, or perhaps a guard escorting a prisoner. For the first time since the Cold War, the world superpowers were staring at the same mystery and drawing the same conclusion. If Atlas was more than a comet, then it was no longer just a scientific curiosity. It was a matter of planetary security. But while nations argued and pointed fingers, the fragments themselves continued their slow, deliberate approach. Their pulses grew stronger, detectable even by amateur astronomers with backyard antennas. Entire forums buzzed with recordings, beeps, static bursts, faint rhythms. Most dismissed them as interference. But others swore they were hearing the countdown of something vast, ancient, and intentional. The strangest reports came from operators of ground-based magnetometers. Just as with the Andromeda signal weeks before, Earth's own magnetic field seemed to twitch in time with the pulses from Atlas, almost as if our planet itself was resonating, vibrating like a tuning fork to something crossing the void. And so the fear spread not just of impact, not just of debris raining down on Mars, but of contact, the kind humanity might not be prepared to survive. As the debate among governments and agencies reached a fever pitch, the Webb Telescope's operators quietly released another series of encrypted reports. These weren't meant for the public. They weren't meant for the media. But leaks, as always, found their way into the open. Inside the second fragment, the so-called companion object, Webb's sensors detected something no comet should ever possess: light. Not the scattered glow of ice crystals reflecting sunlight, not the ionized stream of a comet's gaseous tail, but concentrated illumination, steady in rhythm, faint yet deliberate. At first, scientists dismissed it as noise, perhaps cosmic rays striking Webb's instruments. But then the glow repeated, a fixed frequency, a pulse that appeared every 11 minutes and 32 seconds, like the blink of a beacon. And here's the most unsettling part. The spectrum of that light didn't match any natural emission known in astronomy. It was narrow, clean, and incredibly efficient, closer to a laser than to any natural star or nebula. To put it simply, the glow behaved less like geology and more like technology. The leaked report described it in chillingly simple language. artificial-like emission signature detected, correlated with secondary object, probability of natural cause, statistically negligible. Even more disturbing, the second object wasn't passive. Its orbit shifted slightly after each pulse, as if the glow itself was adjusting its trajectory, steering it, controlling it. That's when questions began spilling into the scientific underground. Was this truly a fragment? Or had we mistaken the original break as a cometary split, when in reality it was a deployment? One object to mask, the other to act. For those watching closely, the implications were staggering. If Webb was indeed peering into the cold, empty phase of interstellar technology, then humanity had just stumbled onto something no civilization is ever ready to encounter. A machine built elsewhere, now drifting at the edge of our planetary neighborhood. Meanwhile, amateur radio operators continued capturing faint bursts in sync with the pulses. Strange, low-frequency tones. Some claimed, when slowed down, they sounded almost like structured sequences, like instructions. Others swore they heard patterns, repetitions that bordered on language. But the question that weighed heavier than all the rest was this. If the second fragment was emitting signals, then who or what was supposed to receive them? The glow persisted, regular, patient, relentless. As the pulses continued, repeating in their eerie rhythm, Earth quietly shifted into defense mode. You wouldn't know it from the headlines. Most outlets remained silent. But behind the closed doors of NASA, ESA, and the Jet Propulsion Laboratory, every screen glowed with the same obsession. The second object's light signature. Satellites that normally scan the sun were quietly redirected. Military communication arrays were recalibrated under the guise of testing. Even the old Voyager network, dusty and underfunded, was suddenly reactivated, as though humanity was trying to assemble every listening ear it still possessed. And here's what caught attention. The pulses weren't just getting brighter. They were getting closer together. 11 minutes and 32 seconds. Then 11 minutes and 31. The difference was tiny, almost invisible. But for those watching the numbers tick downward, it felt like watching a countdown. In late-night labs across the globe, scientists whispered the same possibility, that the glow wasn't random, that it wasn't natural, that it was preparing for something. Some physicists suggested it might be mapping our neighborhood, sweeping energy across the void to chart or scan. Others argued it was testing response like a lighthouse beam searching for an answer. And a few, the boldest or perhaps the most frightened, wondered aloud if the pulses were a kind of ignition sequence. The leaked web logs didn't help ease nerves. Line after line showed consistent detection of narrowband artificial-like emissions. Not one, not two, but dozens across multiple spectrographs. The data was clean, precise, and undeniable. Meanwhile, whispers began surfacing in amateur astronomy forums. Backyard telescopes caught faint flickers where the second object should be. Grainy footage circulated online. Most dismissed it as pixel noise or faulty tracking. But when stitched together, the frames told a darker story. The second object wasn't just drifting. It was changing shape, longer, sharper, more defined with every pulse, as though it was slowly unfolding. Governments refused to comment. Agencies denied unusual activity. Yet the quiet movement of resources told another truth. Supply chains rerouted, emergency budgets released, and in one chilling confirmation, multiple observatories went offline without warning, citing technical difficulties. The silence was deafening, because silence in science usually means one thing: fear of what the truth might unleash. And so, the question shifted from what is it to when will it reveal itself fully. It began quietly. At first, only amateur radio enthusiasts picked it up, strange bursts of static laced through frequencies that should have been empty. They called it cosmic whispering. Some brushed it off as faulty equipment, but soon too many voices reported the same thing. In Alaska, fishermen claimed their compasses spun just slightly, wobbling between north and nowhere. In the Caribbean, pilots whispered about instruments flickering mid-flight, only to stabilize when they changed course. And across Europe, faint green auroras shimmered in skies where no auroras should ever be. These weren't storms from the Sunday's solar weather reports were quiet. NOAA, ESA, every agency insisted conditions were calm, but still the lights came. Faint curtains of ghostly color trailing across skies from Madrid to Mumbai, as if Earth's magnetic field was humming in reply to something far away. And if you listened closely on an old radio, a shortwave scanner, even some car stereos, you could hear it. A soft, rhythmic tick. 11 minutes and 31 seconds apart. The same interval the Webb had logged, the same countdown. The public never got an official explanation. Governments dismissed it as atmospheric noise. Scientists downplayed it as coincidence. But to those who'd been watching, the stargazers, the sleepless researchers, the ones piecing together fragments of leaked Webb data, it was proof. Proof that whatever lurked near Mars was not silent anymore. One night, in Chile's Atacama Desert, a group of amateur astronomers live-streamed what they thought was just another tracking session. But their telescope, trained on the faint path of the so-called second object, captured something new, a shimmer, not the sparkle of ice or dust, but a line, straight, metallic, stretching against the black like a blade, catching starlight. The feed cut within minutes. Some claimed it was bandwidth. Others claimed it was something else. But the clips that survived, grainy, pixelated, still circled dark corners of the web. And then came the dreams. Reports scattered across forums and late-night radio shows, people describing the same visions. A light pulsing through darkness, pulling them toward something they couldn't see. Different people, different countries, the same story. Coincidence? Suggestion? Or something stranger, something reaching across the void, not just touching our skies, but touching us? NASA never answered. ESA never admitted it. But the timing was impossible to ignore. Every tick of the pulse tightened. Every flicker in the sky lined up. And Earth was listening, whether we wanted to or not. The first official cracks didn't come from a press release or even a public briefing. They came from whispers. In Houston, a technician posted anonymously on a late-night forum, "We're not tracking just one object anymore." The post was deleted within hours, but not before screenshots spread across Telegram groups and Reddit threads. It was dismissed as a hoax by most. But to those already watching the skies, it felt like confirmation. Then came a string of strange resignations. A flight dynamics engineer at NASA, a data analyst at ESA, a contractor at JPL. Each one left quietly. No interviews, no goodbyes. But their timing was suspicious, each departure coming just days after Webb's newest batch of classified data arrived. And then there was the recording. A journalist from Madrid, claiming to have a contact inside ESA, leaked a short audio clip, just 27 seconds long. A voice, tired and shaking, saying, "It's not a fragment. It's not random. The signals are too clean, too deliberate. Every pulse lines up with a few disturbances. This isn't breaking apart, it's steering." The journalist vanished from the conversation soon after, claiming she had been advised not to continue reporting. But the audio still circulates in shadows of the internet. Meanwhile, the mainstream media played catch-up. Headlines in late-night broadcasts framed the event as a cosmic curiosity. Phrases like possible fragment and unusual but natural became common. NASA spokespeople appeared calm on camera, repeating words like routine monitoring and within expectations. But behind the scenes, things weren't routine at all. The US military reportedly redirected satellites to watch the region of Mars more closely. ESA quietly rescheduled several launches without public explanation. Even China's CNSA stopped broadcasting its Mars relay telemetry, something they'd been eager to showcase only months before. And yet, the sky betrayed them. Amateur astronomers kept uploading footage, short bursts of light near Mars, the faint shimmer of a second object dancing where nothing should be. Too many angles, too many different people across continents to all be dismissed. One clip stood out above the rest. A man in Australia, recording from his backyard, captured a streak that seemed to move against the stars, not with them. Slow, deliberate. He uploaded it, confused. Hours later, the clip was gone, his account locked, but copies survived. They always do. It was becoming clear. Someone or something was not just passing by. It was acting, adjusting, responding, and the world slowly, reluctantly, was waking up to that fact. At first, most people didn't even notice. The news framed it as technical, too abstract, too buried in jargon for the average listener. But then, the sky itself began whispering hints. A truck driver in Nevada swore that his CB radio caught a strange repeating tone. Not static, not interference, but a pulse. Slow, deliberate. Every 17 minutes, like a metronome beating through the night. He uploaded the recording, laughing nervously, saying, "Either I've tuned into aliens or my truck is haunted." Within days, his clip was dissected across forums, with some claiming the tone matched the observed bursts near Mars. In Tokyo, an amateur astronomer live-streamed his telescope feed to a small audience of stargazers. Just after 2 a.m., a flicker crossed his view. Not a satellite, not debris, but a light that pulsed back. He whispered on the stream, "It knows we're watching." Moments later, his channel was offline. Meanwhile, across Europe, children looked up and noticed something their parents couldn't explain: two tiny stars dancing closer to each other near the horizon. Too faint for adults to catch without equipment. But children's eyes, sharper, unfiltered by skepticism, saw the impossible. Parents brushed it off until one mother snapped a photo on her phone. When zoomed in, the image showed not just light, but structure. And then there were the power surges. In Brazil, entire neighborhoods went dark for exactly 17 minutes. Power returned on the dot, leaving engineers baffled. No solar storm, no grid overload, just silence, then light, as if the blackout itself had been timed. The coincidence was too sharp to ignore. Every disturbance, every flicker, every signal, all pulsing in harmony, a rhythm, a countdown. For the first time, the story broke into living rooms not as science news, but as fear. Talk shows debated whether governments were hiding something. Conspiracy channels swore this was the precursor signal for something larger. Even mainstream anchors looked shaken, fumbling over their notes when viewers sent in videos of strange lights flickering across different skies. And yet, through it all, the official word was silence. NASA denied anomalies. ESA avoided press questions. China remained mute. But the silence was louder than any explanation. It wasn't just scientists staring through telescopes anymore, it was the world. Millions of ordinary people, every night, looking up at Mars with naked eyes, wondering if those faint glimmers were truly stars or something else, watching back. At first, the events felt random. A radial pulse here, a blackout there, flickers of light caught by restless eyes at midnight. But then, the patterns began to align. In Switzerland, a team of graduate students stacked magnetometer readings from across the globe, data from Brazil, Japan, South Africa, even old Soviet-era stations that still fed into open databases. The result chilled them. Every anomaly fell into the same rhythm, 17 minutes apart, like a heartbeat echoing across Earth's magnetic field. Meanwhile, in a control room at NASA's Jet Propulsion Laboratory, engineers quietly confirmed something they had feared for weeks. The pulses weren't just hitting Earth's magnetosphere, they were shaping it. Tiny ripples in the field, timed so precisely they couldn't be chance. One engineer whispered to a colleague, "It's like it's knocking, waiting for us to answer." But the real shock came from Webb. Pointed once again toward the interstellar wanderer, what scientists were still calling a comet, though fewer and fewer believed it, Webb caught something impossible. Not just the usual reflection of sunlight off ice and rock. No, this was a glow, steady, artificial, a band of light running across the object's fractured surface, like the faint edge of a machine stirring in the dark. The public didn't hear about this, not officially, but rumors leaked fast. A journalist for an independent science blog hinted at a moving light source near Mars before her article vanished within hours. Still, the internet remembers. Screenshots spread, forums ignited, and suddenly the word countdown appeared everywhere. 17 minutes. Tick. 17 minutes. Tick. Across the world, clocks were set not by time zones, but by the next expected pulse. People live-streamed themselves waiting, holding up radios, compasses, even their own heartbeats, trying to feel in sync with the rhythm of something no one could explain. And then came the shift. For weeks, the pulses had been consistent, predictable. But on the night of September 17th, the interval changed. 16 minutes, then 15, and for the first time, the pulses weren't just absorbed by Earth's magnetic field. They answered back. Compasses jittered. Drones lost balance. Smartphones buzzed with ghostly static at the exact second of each new pulse. Entire power grids hummed as though something invisible had brushed against them. It was no longer a question of if something was happening. It was a question of when. The countdown had begun.